Hello, thank you for spending some time learning more about our latest publication entitled Laser-induced transient skin disruption to enhance cutaneous drug delivery. I am Sergio del Rio, the first author of the manuscript, and in the next minutes I will guide you through the major results of the project. Ablative lasers have proven to be a very effective strategy to increase the cutaneous delivery of drugs. However, probably due to their invasiveness and aggressiveness, they have not progressed as expected to the clinic. In this manuscript, we decided to evaluate another version of medical lasers, as is the transient skin disrupted lasers. In contrast with the ablative variant, the laser beam in transient skin disrupted lasers is not directly focused on the skin, but on a transducer material that, as a result of the conversion of light energy to mechanical energy, generates resonant amplitude waves. The first part of the study was focused on the screening of optimal conditions for the generation of ROS in vitro. To do so, elements such as direct or confined ablation of the transducer, different laser parameter settings or different transducer materials were evaluated. Once the experimental conditions were identified for each transducer, the ability on increasing the cutaneous delivery of FITC was assessed. Our results demonstrated the ability of ROS to deliver FITC to the viable epidermis, whereas, under passive administration, FITC remained retained in the stratum corneum. Moreover, and as the circular dotted lines highlight, it is visually appreciable the zones where the ROS disrupt the skin. After demonstrating the safety and effectiveness of the technique on increasing the cutaneous delivery of FITC, we decided to conduct a series of short-term permission studies to evaluate the impact on the delivery of commonly used drugs in dermatology, diclofenac and lidocaine. These experiments resulted in increased delivery of both molecules to the skin, comparable with the cutaneous delivery to those observed using ablation-assisted drug delivery under the same conditions. However, and especially when considering the results observed for the fluorophore DID, it is clear that the extension of the penetration was not only affected by the ROS, but also by the psychochemical properties of the drug marker and the co-administration of chemical enhancers. In brief, this manuscript demonstrates that ROS provide a non-invasive procedure that avoids skin damage on the patients, which, in combination with specific formulation strategies, is a feasible alternative for the cutaneous delivery of drug candidates when a short onset of action is required.